Yep, looks
Okay.
good.
Yep, we can.
So, so the title on the agenda is actually Troubleshooting Analytics and Forensics with Journal Files and the syslog. And then I said, any title that you can't say without catching your breath in the middle is too long of a title. So I'm just going to call it Fun with Forensics. This is the obligatory marketing slide on YaraDB. This is the obligatory marketing slide on Octo. And again, just to refresh for those who aren't quite familiar with it, the
We're
core
not
of what
getting
we have.
the slides changing yet.
Oh, okay.
We're still.
They're changing for me, George.
They are changing for me too.
Oh, I'm sorry. Must be me. Sorry.
Okay.
Okay, so again, people have seen this before. At the core is the database, and then we have an M and a C subsystem, and then we have SQL engines and other. Okay, so a database has state, and then what we're trying to do is analyze what changed and when. And again, those who were here earlier saw this slide, which is basically the database can have a state. And just to change the thing, maybe it says that Bhaskar has $1 billion in his bank account. Not quite true, but one can wish. Um, but what's important is that the path through state space is also important, which is like who actually put that $1 billion in the account and when and why, and then the issue is again database state changes, especially for databases that are changing. The state changes can actually be more complex than the database state itself. So if you want to do analytics and forensics, how do you find that needle in a haystack? And so, where we came with this is, well, databases can store a large amount of data, and SQL can query a large amount of data. So we said we can, on the left is the application database file, and that all the state changes in the database file are captured in journal files. So what we can do is actually take those journal files, and we wrote a program called ydb-jnlf that captures the journal files and loads them into another database. So this is a database that just captures the state changes of the original application database. And so, this is a large database, but this database itself should not be journaled, because if you journal this database, then you're journaling the state changes to the state change database, so that ends up being a huge set of journal files. And besides, if you have the journal files themselves, there's no reason to journal the database. So it loads it into a database, and it also generates a DDL, which Octo, which is our SQL engine, can now use. And now you can run SQL queries on the database file. So now you can query who exactly deposited that $1 billion in Bhaskar's account and when. So YDB JNLF is a standard YOTODB utility routine. It's documented in the programmer's guide. And it has basically two labels. So the first label is ingest, and here you can ingest the journal file into the global variable %ydb JNLF. Actually, there's a typo on this. The ydb in the global variable name should be lowercase. So all uppercase global variable names starting with uppercase %y actually have a special meaning. So it's %lowercase ydb JNLF. And the reason there's an optional label is if you're reading the database, the journal file of a database which has not been tagged with a timestamp or something like that, it can essentially overwrite existing data from another journal file. So you can optionally put a label on it. And then the other label in the routine is octo at ydbjnlf. That produces the DDL that octo reads. And if the global directory does not have a ydbjnlf region, the routine will automatically create it. So this is what the documentation looks like. It's in the docs.yatadb.com in the M Programmer's Guide. Okay, so let me do a small demo. And again, this is always my philosophy for demos and playing pool. And I take heart from the fact that about 20 years ago or something like that, Bill Gates was at the Consumer Electronics Show, which is, I think, one of the largest electronic shows, and he was demoing, I think it was Windows XP. In the middle of the demo, he got a blue screen of death. So I can't match that, but hopefully I won't have to. Anyway, let me just stop sharing and share a different screen. Okay, so all right, so can you see my terminal out there?
I can.
Okay. So now I'm going to be copying and pasting a bunch of things in there from another from a text editor. So I don't really type this fast. Okay, so I'm just looking at my database regions, and as you can see, I've got some database files and some journal files. And now what I'm going to do is run a program. And what this program does is basically just capture something called the collage sequences for the length of the collage sequences for numbers from 1 through a million. And a collage sequence is like, it's called a 3n+1 sequence. So if you take a number like 5, the rule is that if the number is odd, the next number in the sequence is 3 times that number plus 1. If it's even, you divide it by 2. So if you start with 5, the next number in the sequence is 3 times 5 plus 1, which is 16, which is even. It takes you down to 8, and then to 4, and then to 2, and then to 1. And one of the great unproven results in number theory is that all of these sequences eventually end up in 1. But what you don't know is what the length of the sequence is and how many steps it takes to get there, and also what the largest number is along the way. So in the case of 5, the largest number is 16. So anyway, so the program runs multiple processes that calculate the different 3n+1 sequence lengths, and it comes back with some results, and the results are basically that the sequence that had the largest number of steps is 524. The largest number encountered was 56,991,991,483,520, and so on. So as far as this demo is concerned, it's just a program that did a bunch of work. So now if we look at the you'll see that the journal files have changed. So if you look at the ydb yatadb.mjl file, you've noticed that it has significantly increased in size as a result of running the program. So now, excuse me. Now what I'm going to do is I'm just going to ingest that journal file into another database, into a different database region, and this is going to be the ydb jnlf region. So it's It's basically doing a mupip extract of the journal file and then loading that into the global. So it takes a few seconds to run. Okay, and it's done that. So now what I'm going to do is I'm going to look at the Octo DDL for that for the global variables that it has imported, and so I'm going to run the Octo DDL label in YDB JNLF, and let me pipe that into this. So you can see that it's created these tables, and now if we look search for type 1, so there's the table entry for operations that include sets and kills, and so these are the journal records, and they're going to be in this global variable called %ydb JNLF type 1. Okay, so this is generating a DDL that you can feed into Octo. So that's exactly what we'll do. Okay, so Octo has now accepted that journal. I mean, accepted the DDL. So now let's run Octo, and now let's run a SQL query. So basically saying, give me the autolog time, PID, the global variable name for a set, the global variable reference, and the value of that node, and it's going to get it from the YDB JNRF type 1 table. I'm going to order it by descending order of autolog time, so you see the newest sets first, and I'm going to limit the result to 20 rows. So it runs for a bit, and the way that Octo runs, it automatically creates cross references when it's needed. So the first time you run a query, it will actually take a longer time to run because it creates all of the cross references that it needs. And the second time you run it, the query will run much faster because it already has the cross references. And then with YATADB triggers, the cross references are automatically maintained. Okay, so these are the results of the output. And again, if you're interested in what they mean, I can tell you. But right now, it's nothing other than there's a bunch of global variables that got set to a bunch of values, and you can see that the time of day, is 56,411, and then it gives you the PIDs and the global variable names. So here we have an octa query. Okay, so now what I'm going to do is exit octa, and I'm going to show you running the same query from um, a GUI tool. So I'm going to start a tool called Rocto, which is the remote Octo server. And so I'll start that. It's listening at port 5332. And I'm going to share a different screen with you. Okay, so this is a program called dbeaver. It's an open source SQL tool. And Octo is basically designed so that it uses the Postgres driver for ODBC and JDBC. So we don't have to write our own drivers, or you can just use the existing Postgres drivers. So here's the database, and now you can go and see that it's out there, and it's got and then there are a bunch of tables in there, and a lot of those tables are actually just metadata tables that Postgres generates and we mimic, but you can see the YDB JNLF table. So now let me run that same query that I had before. Right? Why is it not? Let me disconnect and reconnect. All right, I may have to. Sorry, I have to turn on the firewall and open the port. Sometimes it asks me to do that, and sometimes it doesn't. So just give me a moment. Oh, I see the problem. I had the wrong port. Okay, now we're done. We've got the connection. It would help if I got the right number for the port. Let me run the query. Let's run in the query. There's a small hiccup in using dbeaver as the client, by the way, so we're working on it, but it shouldn't take this long to run this query. It should just be virtually instantaneous. But anyway, here we are. So now you can see that we have the same results that we got before. And so now we can query the journal file and we can find out, who set what global variable when and who killed what global variable, all of those things. So I'm going to.
So what, Bhaskar, my curiosity's killing me. What are those strange looking things?
Oh, those are just numbers in different languages. So you can see, for example, that there's, de is French, tres is Spanish. So one of the things that the program does, and it's just kind of a cutesy thing, is when you have a number like, 1056, it converts that to 1 space, 0 space, 5 space, 6. But each of those digits is spelled out in different languages. So it's
So
just a
that
cute.
thing with the line over the top of it is a number and it's in a
Yeah,
language?
that is up on the second row, for example, that is Sat, which is Hindi for 7.
Oh, okay.
So, it was just something to show that we can handle different languages in the, in
Yeah,
a YDB program. So it's not intended to be useful, it's intended to be cute.
thank you.
Actually, at least let me put it this way, cute to a geek. I don't know about cute to someone who has any artistic talent. All right, so
So
that's
what
the.
does that mean? Bhaskar, what does that imply for what character sets your what's the character representation then
Oh, this is
in Octo?
UTF-8. UTF-8.
Okay, great. So right. So that's different than So that's a setting in YadaDB, right?
Well, it's a when a YadaDB process starts up, it there's an environment variable that you set which tells the process whether to start in M mode or UTF-8 mode. And
Oh.
as far as the database is concerned, there's no difference because from the
Hmm.
database's point of view, something is either a string of bytes or it's a canonical number for subscripts.
Hmm.
And so the difference between M mode and UTF-8 mode has to do with things like, dollar piece, dollar length. So dollar
Right.
piece and dollar length are the lengths in characters, whereas we have functions dollar $z piece and dollar $z length, which are always the length in bytes.
I see.
I
Okay.
mean, there's a
Thank
further
you.
complication which I won't go into out here, but I can certainly talk about it at some point, which is that in UTF-8 there's also the width. The width of a character is different from it could be one glyph or two
Oh,
glyphs or whatever.
right. And that the width has to do with the print, how it's printed, right? It's
Yeah.
kind of a kerning kind of thing.
Yep. Yep.
Okay. So
So you
so
can have zero. Go ahead.
so are the so when you say mumps mode or UTF-8 mode, does that mean that if you're writing software, you're writing code in mumps, you'll be in mumps mode, I guess. And if you're writing code in C or in Perl or in Go or Rust or R, I don't know, would that all them all they would those always be in UTF-8 mode, or you could choose,
Well, so as I said, the database doesn't care what mode it's in. It's entirely
right?
in the M code.
Right.
Now, languages that are are newer than M, basically, I mean, like C, it has functions for interpreting a string, in terms as double wide or as UTF-8. So there are
Right.
functions for doing that. And some languages, everything is, I think, UTF-8 Unicode.
Okay. So it's really know your data when you're writing the code.
Oh yeah, definitely.
All right. Thank you.
And it gets even more complicated than that, but
Yeah.
that's for another day.
Thank you.
All right, let's get back to the presentation. Okay, so moving on. So now, we talk about using a database to analyze changes in other databases. Well, computers are where databases live and where software lives, and syslogs basically are, I mean, they do more than capture changes to the state of the computers. They also capture, as to who changed what and when and why. So, and a computer is a much bigger state machine than a database. And of course, a network of computers is even bigger than that. And sometimes if you're doing forensics and troubleshooting, you have to look across computers to say, what happened within this period of time across my different, x86 systems, for example. And so putting all of that in a database makes it easier, I should say, to analyze it. And so YDB syslog is actually a plugin. So it's not automatically included with every AutoDB distribution. It's a plugin, which means that you can install it with YDB install. And we have a separate plugins manual for documenting all of the plugins. And so roughly this is what it looks like. So there is a syslog, and there is and on most Unix systems these days, the syslog is systemd, and there's a tool called journalctl that extracts or exports the data in syslogs. And YDB syslog, %YDB syslog then takes that journal export and it puts that into a database. And typically when you start YDB syslog, you'd want to do it you want to have two processes essentially. The first one will basically do a follow. so that as it keeps running, as additional entries get put into the syslog, it captures them. But of course, that only starts at the point that you start it. And anything prior to that will not be in the database. So if you want things that are prior to the point at which you started the YDB syslog with the follow, you start another one which runs journal CTL, and you can tell it to capture all boots that the system D has captured, or you can tell it just the current boot. So there's a bunch of parameters that you can give it. So you start these two processes. One of them will end, the one that that you start later, which captures the current boot or all boots. The one that you say follow the syslog, that's going to keep running, and the database is now getting the syslog data. YDB syslog can also, like YDB JNLF, export an octo DDL, and then you can run SQL queries with octo. So now again, let's go back and do a demo. This time I'm going to go to this tab. And I already have a database that has captured the syslog on my laptop. So I'm not going to show you the capture. I'm just going to show you the DDL. And so again, there's a table. It's called syslog data, and there's a 100 and some fields. What's interesting is that some fields are binary, and the global variable where it's captured actually has a dollar data. The nodes have dollar data of type 11, because you can have the binary fields below it, below a node that actually has the structured data. But in the case of exporting that as a SQL table, it's essentially just one table. So one of the capabilities of Octo is that a table can map part of a global. It can actually map parts of different globals. So it's very flexible as to how you map global variables to columns and tables. So this is the table definition. And then at the end, it tells you what global it's in. So the global it's in is called YDB slog. So now we want to take that and want to put that into Octo. Okay, so Octo has now read the DDL. So now let's run a query. I'm just going to copy paste. So it's running a query where I'm saying select the real time, and the real time timestamp is basically the number of microseconds since the Unix epoch, which is January 1st, 1970 UTC. So I'm basically saying capture the Unix timestamp, capture the PID, capture the command line, and do it for UID equals 1037, which happens to be my UID. And I said capture that where the program is either mupip or it's YARDADB. And then I tell it to basically order in reverse order of the timestamp, so you get the most recent timestamps first. So this is what's in the syslog. So now what I'm going to do, and as you can see, the most recent command I did, which is right on top, is a YARDADB direct command. So now let me exit Octo. And what I'm going to do now is mupip command to set the journal and regions. So now let me go back into Octo. And now I'm going to execute that command again, that query again. And now you can see that the top command was actually a new pipset journal, and the YotaDB direct commands are less recent than that. So the system is actually capturing these updates in real time. Okay, so now I'm going to show you the SQL from the GUI. So let me terminate that. And what I'm going to do is start the web browser. Sorry, the web server, not the web. And then I'm going to go to a browser. So anyway, here's the web server. And let me share. So now I've got a browser, and let me connect to the GUI. So there's the GUI, and there's a whole bunch of stuff, and Sam's going to talk about this in more detail when he gives his talk. So I'm just going to go to Octo and run a query in Octo, and I'm going to take the same query that I ran before. So it's executing the query, and now you can see that you got the same results in the GUI that that you saw before. And now if I go back to my presentation, so when we do this for multiple machines, this is actually what we have running on our system here. We have the syslogs on the different machines. So there's a host machine, and the host machine is the one where the boxes are in orange and the lettering is in purple. And that host machine has the database where you can run queries across different machines. And then the boxes where you have the lettering in orange and the boxes themselves, the lines are in purple, those are running on the other servers. And each of them is running the syslog, running journal CTL. And again, there's actually two journal CTLs, as I mentioned before. It runs netcat, and the netcat now puts that in on on the machine where all of the databases, all of the data is being aggregated, and it goes into that central database, and then we can run queries on that database. And as of now, we've been doing this for somewhere between 1 and 2 months, and the database is on the order of about 200 gigabytes. So I think at some point we're going to have to start, pruning the data. But right now, it's a terabyte disk, so there's plenty of room for it to grow. Okay, and that's the end of the slides, and I'm open to any questions, comments, concerns, Rotten Tomatoes, whatever.
Bhaskar, I didn't understand. Let me see if my mind may be blown here. So what you showed on that last chart, is something where you've got you've got a couple of machines, two or more machines running, producing logs
Hmm.
and journal, and you're running this syslog. And it now, is that a big batch process? You run it and gather all the stuff and then do your queries, or you had intimated before that the things will be doing in real time.
It's
Do
real time.
those It's real time?
It's real time.
So those so when you're running that syslog or whatever program, it's actually it'll sit there and wait until there's something else. So it's
Right.
a pipe. You're talking about a big pipe of a
Yeah,
pipeline.
exactly. Exactly. And actually, that's why I said when you start the syslog, you want to start two of them. So the first one is run in what is called the follow mode. So you're basically following the syslog. And from the moment that you start it, it will pick up all of the syslog entries from that point on. And then you start another one that says, give me all of the old stuff or all of the current stuff, and then this is your decision. You can say, give me all of the stuff for the current boot. You can say, give
Right.
me all of the stuff you have. And the second one is finite. So once it's done giving you the data, it's going to stop. Whereas the first process then, is essentially sitting out there, and as new entries come into the syslog, it just picks them up and puts them in the database.
That's fabulous.
And so what happens is, like for example, on our machines out here, when we, every so often we patch all of our machines. So after patching the machine, we basically start it up again. And then when starting it up, we basically say, do the give me the stuff in follow mode, and then give me the stuff from the current boot. And so
Wow.
all of that gets collected in that one syslog, and then it is a continuous process.
Wow, that's incredible. So if you're talking about setting up a cloud instance of many YadaDB uh, servers, doing stuff, their activity is this is a way that their activity is consolidated,
Correct. And
and
it doesn't
so
have to be just YadaDB. I mean, YadaDB, of course, is the database, but those machines could be running whatever you want them to run.
oh my God.
Because the syslog is a syslog. That's where it keeps track of all of the users that log in. It keeps track of all of the processes that run. It keeps track of whatever
Oh my
by
God.
default, it keeps track of everything.
That's
And
cool.
part of what setting up a Unix system or a Linux system is, if you're an expert administrator, is that you get to configure what goes into the syslog.
That's incredible.
So,
So
s-
what is that stuff that there I haven't heard the term in a while, but where MongoDB is being organized to do what's it, hash and no, I don't know, it's something like
And
map and map reduce.
yes, yes.
Map reduce. You can have real time map reduce.
Well, we're not doing so much of MapReduce as just consolidating everything into one huge database. And
Yeah.
of course, since you have replication, you can now take that database and you can replicate it to another data center that's far, far away.
Yeah, but MapReduce is not, as far as I know, continuous and real time at all.
Yeah,
So
I don't know that much about it. Okay, so
this is wild. This is very wild. I love it. Thank you.
so, so Bhaskar, if you wanted to set up something to watch for an attack, for instance, on your by querying your logs, you could write something that says, "Go ask for this, and if you see this, put off an alarm," something like that.
well, you can run a SQL query. So even though the data is being aggregated in real time, the SQL query just is not doesn't run continuously.
Right.
So you'd be running the query once a minute or periodically to get that to find out if that event happened. Now, since YaraDB has got database triggers, depending on how fancy you want to get, you can easily set up a database trigger that says, if this particular event happens, then raise a ruckus.
Yeah, I got you. Okay, good.
This is very cool. So you're basically promoting this stuff to be able to seriously impact real time applications.
Well, that's the idea. I mean, for us to grow, we really would like to have more people using the database for different things.
Yeah. This is great. Wow. I say wow. My mind is blown. Very cool.
Right. So
Thank you.
Okay, are there any more
thank.
questions? You timed that perfectly, Bhaskar.
Well, the thing is, so last time evidently I spoke too fast when I did my update
Yes,
talk,
you did. You
and and
talked very fast.
and this goes back to the story of how I got my first American driver's license. So I came to the U.S. as a grad student in 1975, and I had driven in India before coming here. So when I went for my first driver's test, that was the first time ever in my life that I'd driven in snow. So I flunked the test for driving too slowly. So then I went back a couple of weeks later, and this time I flunked it for driving too fast. So the third time I got my driver's license.
Okay, I see Patrick is here, but I don't see